Welcome to UVU CS3060 Lecture 7.0, where we give a synchronization example called the bounded buffer problem. So the bounded buffer problem is going to be important to you because you will write an assignment based on this particular problem. You will have two threads. One will be a producer of items that will go into a buffer, and the other will be a consumer that will pull values from a buffer. You will use bounded buffer to accomplish this. Now, in order to use a bounded buffer, you will have a buffer of n items. It says n buffers, each can hold one item, but you'll have a buffer that contains n items. You'll have a mutex, and you'll have a full semaphore and an empty semaphore. Now, you can actually do this without the mutex, but you're welcome to use it as well. But it really is the full semaphore and the empty semaphore that matter. The full semaphore indicates how many values are in the buffer. When you first initialize it, full will be initialized to 0, meaning there are 0 items in the buffer. The producer will check to see if this value is 0 by performing a wait on full. And whenever it sees that there are, the consumer will will do a wait on full. If there are 0 items in the buffer, the consumer will wait until this gets bumped up to 1. You'll also have an empty semaphore. This semaphore will be initialized to n, and this is how many empty spots there are in the buffer. The producer will wait on this particular empty semaphore, and clearly, since it's initialized to n, it will be able to proceed and add items. The producer will put items into the buffer and then decrement, and then this empty will be decremented every time it is checked. The code will look a little bit like this. Now again, the mutex isn't entirely necessary. You don't really need to set this if you work with the buffer properly. The key here is the semaphore is the critical section. The empty semaphore for the producer is the critical section where the integer variable is going to be decremented. Remember, empty is initialized to the number of empty items in the buffer, or n. So the first time we hit this wait, it decrements it and is able to continue on to produce a value into the buffer. The mutex is not necessary for our particular solution. You will use this mutex if you have multiple producers. If you've got multiple producers working here, then this mutex becomes important. But whenever the producer is done adding an item, it will actually send a signal to full, incrementing full initially from 0 to 1. Now if we go to the consumer process, the consumer will wait on full. Now remember, full is initialized to 0, so when a consumer comes in here, it's actually going to wait until the producer adds an item to the buffer. Again, for our particular assignment, mutex isn't necessary unless we have multiple producers and consumers. After the consumer has removed an item from the list, it's able to signal empty so that it can increase the count of empty items and allow the producer to use that new empty item. This is the producer-consumer system, and you will implement something like this in your assignment. This brings us to an end of Lecture 7.0, where we talk about the bounded buffer problem.